In this problem, we're given a time or a variable x here that indicates the time needed to assemble a car, and x is distributed according to a normal distribution. That's what this means. We're given the population mean, mu, is equal to 80, and the population standard deviation is equal to 5. And for our purposes, we're just going to assume that the total population size is some very large number. Might as well be infinity here, okay? We're asked, what is the probability that for a random sample of 28 cars, that the sample mean is going to be greater than 85? Okay, so in this case, let's just go ahead and mark that our sample size is 28. The first thing that we need to do is we need to find what the sample standard deviation would be. What is S? And in this case, we can estimate it. And we're using a formula for S, or sometimes what you might see as the standard deviation for x bar. And this is found in chapter 7. This is equation 7.3 on page 320. This is equal to the population standard deviation divided by the square root of the sample size. And we know both of these. They're given to us in the problem. This is 5 divided by the square root of 28, which gives us 0.9449. We can't necessarily assume that the standard deviation of the sample size will equal the standard deviation of the population. Now, at an x bar equal to 85, we need to compute a z-score. And again, remember that z is equal to x minus the population mean over the sample standard deviation. We have all of this as well. 85 minus 80 over 0.9449. And using our z table, we find that this is a score of 5.29. That's a pretty high z. You can also find this by plugging this in to a calculator. Okay. Now the probability that z is greater than 5.29 is equal to 1 minus the probability that z is less than 5.29. Now if you plug that into a z probability of z calculator, because this is actually a value of z that's large, so large that you won't find it in the back of the book in the z table. What you'll find is that the probability that z is less than 5.29 is very, very, very close to 1. In other words, this whole thing here is equal to 1 minus 1, which equals 0. Okay, so the probability that the sample mean is greater than 85 is actually 0%.